right, so thank you very much for having with us here, and then it's very good afternoon. So welcome to APIEMS 2021 webinar 2, which covering about contactless logistics. Let me introduce myself. I'm Helmi Ali from Universiti Kenbangsaan Malaysia, Graduate School of Business. So it is my pleasure to be given this opportunity by Jackie, Prof. Min Lang Cheng, and Asia University as the organizer to co-host this APIEMS 2021 webinar series 2. So today's webinar will be around contactless logistics, which will be given by Professor Wong Wai-Peng from Universiti Sains Malaysia. And together with us today, we have Prof. Kono Hiraokazu, APIEMS President from Keio University, and also Prof. Chen, President of CIIE from Tsinghua University, Taiwan. So without further ado, I would like to introduce our Professor Kono as opening remarks. All right, Professor Kono is a professor in the area of productions and operations management, and a former dean at the Graduate School of Business Administration, Keio University. He received his degree and PhD in Administrative Engineering from Faculty of Science and Technology, Keio University. His research interests include industrial engineering, production planning and management, engineering economy, and management of manufacturing firms. He has served as a president of Japanese Institute of Management Association, and currently he is a president and fellow of Asia Pacific Industrial Engineering and Management Society, which APIEMS that we're having today. And then he also is the editor-in-chief of IE Review at Japan Industrial Institute of Industrial Engineering and president of APIEMS for 2021 and 2022. So without further ado, I would like to give the floor to Prof. Kono for the opening remarks.
Thank you, Professor Ali, and good afternoon, everybody of the APIEMS Society. I'm glad to be able to give my opening remark from here in Japan. And I'd like to first express my gratitude, probably our gratitude from APIEMS Society to the organizers, especially to the CIIE members for planning this sort of excellent series of webinars. And people may regard that this period is a very difficult period, but if we look at the the role of the APIEMS, probably we need to be able to contribute to somehow the future of the society and industry through our research and research outcomes. Probably the situation of the coronavirus is slightly different country to country, but as a whole of the region of the APIEMS, Asia Pacific, we have to take some action, take some initiative toward the future. In this respect, I regard that this sort of webinar to wait for our face-to-face conference in December 2022 in Taiwan is very important. And also, on top of our contribution to the society, our theoretical outcomes in terms of industrial engineering and management science research should be enhanced and encouraged. In this context also, this webinar seems to me very important. And as president of APIEMS, I would like to contribute to the development and enhancement of APIEMS society, and also this seminar can contribute to the solidarity of the APIEMS society. Thank you once again to the organizers, and I look forward to seeing you in person and also through video in the future. Thank you very much.
Okay. Thank you, Professor Kono. So we also have another opening remarks by Prof. Chen. Let me introduce Prof. Chen to us today. Prof. Chen is a Tsinghua Chair Professor and Micron Chair Professor, which is sponsored by Micron Foundation USA in the Department of Industrial Engineering and Engineering Management in National Tsinghua University, Taiwan. He also is president of Chinese Institute of Industrial Engineers that was founded in 1962 in Taiwan. He is also been the director of Artificial Intelligence and Intelligent Manufacturing System Research Center that is one of the AI centers sponsored by Ministry of Science and Technology in Taiwan. He also the founder and chairing professor for Decision Analysis Laboratory Lab in the National Tsinghua University as well, if I'm not mistaken. And then he is a Fulbright scholar in the Department of Industrial Engineering and Operation Research in UC Berkeley. He was the visiting professor in Institute for Manufacturing, Cambridge University, visiting professor in the Beijing Tsinghua University, and also Waseda University, as well as Tianjin University in China. He has been listed currently, the last one is 2% top scholars in the operation field by Stanford Study recently, and Dr. Chen has received many awards in his colorful career. All right, without further ado, I would like to call for Prof. Chen to give your opening remarks.
Thank you, Ali. Dear President Kono and Ali and distinguished guests and our keynote speaker Wai-Peng. This surely our great honor, especially during this crisis of COVID-19, but under the great leadership of President Kono as well as our APIEMS senior members. So we have our team members, especially Professor Chen of ASEAN University, as well as other colleagues, to proactively organize this number of webinars to address the critical, important research issue as well as the economic concerns among various countries, just like President Kono says. So as you can see, we will have 5 webinars this year. I think as like a warm-up, so that we look forward to hosting the next APIEM 2022 in Taiwan, and I look forward to see each of our friends in person in Taiwan, in Taichung. And before further introduction, I just want to briefly share how CIIE in Taiwan we have been doing, try to address related issues. Of course, we still put a lot of effort with the leading manufacturing segment as well as service segment in Taiwan. So CIIE, we have signed a collaboration agreement with leading companies such as semiconductor company, such as TFT LCD company, as well as PCB company. And we recently also established a collaboration with the Alliance for Sustainability Development. That is one of our largest organizations that led by our ambassador Chen in Taiwan. They have successfully to coordinate, especially integrate those corporate research, social responsibility activity, and the sustainability development in Taiwan, and organize a number of seminars. So we found that while industry leaders, they are putting more emphasis about sustainability and the circular economics. On the other hand, the industrial engineering, especially APIEM members or CIIE members, we have done a lot of related research. So through a collaboration, we are going to organize and join a big conference in this coming September, so that we can bring in or integrate our research effort with those industry leaders concerned, because this sustainability, climate change has been global issue and increasing important now. And finally, and also through our members' effort and through APIEMS senior members' support, so we organize a number of special issues that will be announced later that we from time to time, so that we encourage the participant of these webinars as well as other APIEM members. They can contribute their related research to our forthcoming special issues, and we would also using this opportunity to integrate related effort. And finally, we thanks all the support from APIEM, especially from President Kono, from our host today, Professor Ali, from our keynote speaker, Wai-Peng, and as well as our team member. Thank you very much.
Thank you, Prof. Chen. Thank you, Prof. Chen, for the opening remarks. So, today, basically, main agenda is our speech by Professor Wong Wai-Peng. She will talk about the contactless logistic. So, I will do a brief introduction of Professor Wai-Peng. Professor Wong Wai-Peng is from School of Management, Universiti Sains of Malaysia, and then she received her PhD from NUS, National University of Singapore, in the area of Industrial and System Engineering. Under her belt, she has published not less than 50 articles in ISI Impact Factor and other reputable journals. Her research interests includes of simulation optimization, logistic, and supply chain management. Professor Wong received Australian Government Moderators and prestigious Endeavour Executive Fellowship Award, Sumitomo grant for Japan-related projects, and also Newton Unko Oma Fund in 2017. And she also is a chartered member of a Chartered Institute of Logistic and Transport Malaysia. So we are very interested to hear about the contactless logistic. So without further ado, I would like to call upon Prof. Wong to do your keynote speech.
Thank you very much, Professor Ali, Professor Chen, and Professor Kono. So let me share my screen for my presentation. Are you able to see my screen?
Not for me.
Not for me as well.
Okay now?
Yes.
Give me a moment, please, because I need to include the computer sound. Yes. All right. Thank you very much once again for your kind introduction.
Prof, can you do
Slideshow.
screen? Yeah. Slideshow.
Thank you very much once again for your kind introduction, and I'm very thankful to the organizers for inviting me to give this lecture. And I'm very honored to present along with distinguished professors and leaders in their respective field. I must first admit that I'm not really an expert of today's topic, which is contactless logistics. My background is actually computer engineering, and my PhD, as mentioned by Professor Ali just now, is in industrial engineering. My PhD research focused on advanced methodology to measure efficiency, in the real world. I have developed an innovative method using the combined technique of optimization, simulation, and data envelopment analysis to synergize the efficiency and effectiveness objective of the methodology. So, as was mentioned just now, currently I am attached to USM, Universiti Sains Malaysia, which is located in Penang. It is a small island in the northwest of Malaysia. Penang is also known as the Pearl of the Orient, and it is famous for its soft, sandy beaches and, of course, the varieties of food. If you have the opportunity to visit Penang, please do come and visit my university. I will show you around. So this is a brief outline of my presentation today. I'll walk you through what is contactless logistics, what are some of the OR research in this field, and I will share some of my related research work. And then I will end my presentation with some implications and concluding remarks. What exactly is contactless logistics, which is a hot topic right now? This is just some of my opinions. Logistics refer to the process of coordinating and moving materials, inventory, and finished goods from one location to the desired destination. Contactless logistics is also known as contactless delivery. And for most people in the business context, we refer it to contactless deliveries. So the purpose of contactless logistics being carried out is to avoid direct contact between the participants in the logistic activities. For example, if we take the last mile delivery, which is the last stage of the supply chain, this is also the stage that has the most human intervention, or another word, the most intensive contact between humans. And apparently, most technology development for contactless logistics support the last mile activities. So, for instance, the delivery process has evolved from paper-based to digital-based. Traditionally, the delivery man or the courier service guy will pass the package to the receiver, and then the receiver will sign on the document as an indication that he or she has received the package, and the documents are then passed back to the delivery man. Then it gradually transforms to digitalization, where paper documents are no longer needed, and the receiver just needs to sign on the tablet or a device to confirm delivery. Well, this has actually eliminated much of the waste and inefficiency associated with paper documents. And lately, there is also the self-pickup and delivery mode, such as the Intelligent Express Box and Smart Lockers, which are becoming a norm in the logistic industry. These equipment are essentially rolling out the transformation from D to D, which stands for delivery to the doorstep, to D to C, which means delivery to the cabinet. Likewise, in Malaysia, my home country, our National Postal Service is collaborating with 7-Eleven store to provide consumers more options to pick up and deliver their parcels. Malaysia's e-commerce market is projected to double to about $8 billion USD by year 2024. So it is neither productive nor sustainable for this growing volume of packages to all be delivered to the doorstep. So this form of collaboration is one alternative, and of course, we do need alternative solutions to enhance the last mile delivery infrastructure. And with that, possibly the Parcel 365 locker services could be one alternative too. And right now, the lockers' location are concentrated in the Selangor area in my country. And possibly it could be expanded nationwide. Another example of contactless delivery is the food service industry. For example, the Grab food. Customers will place order of the food at the website or through the Grab food app. The restaurant then receive the order and prepare the order, and customer will then collect the food from the restaurant when it is ready. And so this is one example of contactless in the self-service domain. With the surge in e-commerce accelerated by the virus pandemic and social distancing norm, all these have only increased the consumer demand for contactless logistics. Companies are now embedding more intelligent technology to provide more options of contactless delivery services to their customers. Examples of these technologies are the self-delivery cabinet, convenience service point, like the 7-Eleven store, intelligent distribution robots, and many more. Well, in this slide, you can see some examples of the equipment for contactless delivery. Please note that the level of technology intensity increases from left to the right, with the drone or UAV, the unmanned aerial vehicle, or some people just call it as intelligent distribution robot, now being the most advanced technology used in the logistics sector. The ongoing pandemic has really put a global spotlight on these autonomous or intelligent delivery robots. There is tremendous market interest pushing for the use of these robots to provide large-scale operation. Here is an example of a use case how robots can help in the last mile delivery. In this example, the autonomous delivery robots help to deliver groceries to the residents. So this is an example actually taken from Singapore, my neighboring country. How it works is like this. First, the consumer orders goods through the supermarket online platform and selects the delivery date. Then, the person in charge of logistics will deliver the goods to the dispatch hub in the supermarket and schedule the delivery time with the consumer. After that, the operator will load the goods into the autonomous robot and locks it. Then the robot performs the delivery at the scheduled time, and the consumer will be notified to pick up the groceries. When the robot reaches the collection point at the consumer residential place, the consumer will then collect the groceries by scanning a QR code or key in an OTP, which is sent to their mobile phone to open the ADR. So this is how it basically works in the context of contactless delivery for groceries. And here is another example of how contactless delivery works in hospitals and quarantine zones. Robots are used to deliver food to the patients in the quarantine zone to reduce the level of human contact. And of course, in more developed countries, there are more advanced technologies being embedded in the last mile delivery. These intelligent logistics robots provide the door-to-door service to complete the contactless distribution task. So here in this slide, you can see the different versions and different types of autonomous robots in different countries, like in China, US, Estonia, Korea, and Malaysia is of course slightly lag behind when it comes to technological development. So basically, the mode of operations is that the staff will enter the order information. The intelligent logistics robot will then make the delivery to the owner. It can scan the route, and along the way, the robots are able to avoid various obstacles on the road. Customers are notified of the exact arrival time. So when the robots arrive at the doorstep, some authentication methods is carried out, like through face recognition, sweep code, or input pickup code. So all these are done without any human intervention. Basically, there are three different types of delivery robots available in the market. There are the Starship Robots, the Animal, and the FedEx same-day bot. The features of these robots are best suited for the last mile delivery in the context of city logistics. So take for example, the Starship Robot. It weighs no more than 45 kilograms, and it can travel at pedestrian speed and carry a payload of less than 2.6 kilograms to customers within a 4-mile radius. On the other hand, the Animal can carry a payload capacity of up to 10 kilograms. It can climb over challenging terrains such as curbs, stairs, up to 45 degrees, and other obstacles on the ground. Moreover, the Animal can travel at a speed of 3.6 kilometers per hour with batteries for more than 2 hours, and can ring the doorbell with its foot and drop the package in front of the door. And lastly, the FedEx same-day bot. It has a top speed of 16 kilometers per hour with a 3-mile radius. It has a relatively slow speed, but this helps to make sure that their security implications are not a big concern. Therefore, delivery robots have the potential to provide a cheaper, in the long run, a cheaper, safer, and greener solution to current unsustainable last mile challenge. So now we can compare the differences between traditional delivery and contactless delivery or contactless logistics. In terms of delivery process, in traditional logistics, it is a face-to-face delivery, whereas in contactless logistics, there is very minimal or non-human intervention. And now, because of the pandemic, contactless delivery also include recording and traceability of health information of the delivery staff to the customers. This significantly improves the transparency of delivery operations as customers get full visibility of a delivery executive's health status. In terms of delivery equipment, there is no requirement in the traditional logistics But in contactless logistics, it requires a delivery equipment such as smart lockers, UAV, or robots. In terms of delivery time, contactless logistics will be much shorter compared to traditional logistics. In terms of cost, contactless logistics has higher initial fixed investment costs, but over the long run, the variable cost will be much lower than the traditional option. Now, let's move on to the next part where I will be sharing some research papers on contactless logistics. From the bibliometric analysis which I've done, we can see that contactless logistics is an emerging topic. Before the pandemic, the research of technology in logistics was mainly centered in RFID. And then after the COVID-19 pandemic came out, the wave of contactless research came out. This diagram, this is a network visualization. It shows the bibliographic linkages of contactless logistics with some formal concepts. As we can see here, contactless logistics is closely related to IoT, application context, distribution, warehouse, RFID, and retail stores. So in the context of OR, operational research, what types of research that we can find in the literature? Well, we can see that most of the papers focus on optimizing the routing problem of the equipment. For example, the AGV, the UAVs, and some focus on optimizing the routing mechanism for multi-shippers and carriers in collaborative platforms like the e-commerce. One recent paper in eJour, the authors analyzed the routing of a set of delivery delivery vans equipped with a number of self-driving parcel delivery robots in urban logistics. In that paper, the author developed an adaptive large neighborhood search heuristic algorithms to tackle the vehicle routing problem with time windows and delivery robots. Here is a sharing of some statistics on drone. As you can see, the amount of drones sold in the market increases.
Wong?
Yeah, there's some connection issue at my side. I'm sorry. Okay, so let me repeat again. Here's a sharing some statistics of drones. As you can see here, the number of drones sold over the years has increased dramatically. So this may perhaps indicate that there will be more and more research pertaining to contactless logistics in this direction. Now, in fact, back in my country, Malaysia, the CEO of AirAsia, the budget airline, has recently announced that it will explore urban drone delivery. The global market size specific to drone package delivery is currently at 600 million USD, and it is projected to reach 7 billion USD in 2027. This innovative logistics solution will definitely improve efficiency of the pace of delivery in urban areas. So one of my research relating to contactless logistics is this paper. In this paper, we study how to solve the integration difficulty between scheduling and routing aspects of the multiple AGV through the winner determination problem, WDP, in short we call it. So in this paper, we illustrate an efficient approach using genetic algorithm to decompose the nonlinear combinatorial auction model into a linear model to solve the winner determination problem. In this particular problem, we consider there is a very large number of AGV. So the assignment of routes is very difficult to be solved by conventional MILP, mixed integer linear programming method. We compare three models solved using MILP, conventional GA, and the proposed GA method. So basically, how our proposed GA method works is that first, we enter the GA parameters and the simulated transportation data. And then the knowledge-based initial population is generated and sorted. After that, some of the members that have better fitness values will be chosen as elites and will be passed on to the next generation of population. Then after that, a set of children will be produced by crossover and mutation. So the children will undergo an adjustment functions and form a new generation. So this whole process of elite selections and new population generation will repeat until the stopping criterion is reached. For the results, we found that MILP only works well for small-scale data. When the number of routes and AGV increases, our proposed GA method supersedes the other methods by having lower costs and higher flexibility. My research actually focused more on the efficiency or performance measurement for the logistic players in the logistical supply chain. For instance, in this recent paper, we developed a coherent DEA model to evaluate the efficiency of the sustainable supply chain. This coherent DEA model, or in short, core DEA model, has the ability to avoid the intermediate measures by focusing on the divisional efficiency using the conventional DEA method. This core DEA model serves as an alternative approach to evaluate the supply chain efficiency, which provides consistent results that allows it to avoid missing the essential relative factors between the supply chain members. The identification of essential relative factors such as the intermediate measures between the supply chain members is actually a very difficult task because there are many factors in business world that cannot be treated as intermediate measures. As an example, factors such as reputation, risk, and social responsibilities affect the overall efficiency and not just merely each consecutive stage. So while these factors need to be taken into account for efficiency assessment, they just cannot be treated as intermediate measures. So to maintain the sustainable performance of the whole holistic supply chain, the evaluation of efficiency of a complex supply chain becomes even more challenging. And this core DEA model contributes toward this particular gap. And earlier, we have also carried out a project with the SME to automate or digitalize the inbound logistics. and receiving process to reduce human intervention, which cause errors in their data collection. In fact, this project happened before the pandemic, but the overall concept here is applicable to contactless logistics. We could associate it in terms of contactless delivery of raw materials in the manufacturing industry. So in this project, we engage with a rubber processing company to help the company transform its manufacturing process, which is human-intensive operations, to an intelligent or smart manufacturing process using IT platform. So we help them to improve the verification system by developing a GA and web-based analytics platform for their production confirmation. I will show you some snapshots from the project. So this is the web-based platform developed to collect quantitative data of the wood piece. The GA method is used to confirm the initial data. I will show you the GA part shortly. So data will first key in at the sawing process. The users can use their smartphone to key in the data. The input data will then be uploaded and stored in the SQL database for analysis and report generation purposes. The data will then be shared with the administration staff at the subsequent processes like chemical pressing, drying, and packing processes. So this is the database structure and relationship of data tables are designed according to the transferring of data among the primary process. The tables in the relational database store data related to sawing and receiving process, such as the sawn date, type, whether in-house or purchase, and product description. These data are then linked to the subsequent processes, which is chemical compressing. In the chemical compressing process, the lot number will then be generated and linked to the drying and packing process. And this is the web-based application for data input using smartphone. So basically, the inspector input data using their smartphone. The data will be uploaded and stored in the SQL database and then used for further analysis and report generation. So for the GA part, we applied GA to predict the quantity of raw materials in the receiving process. The challenge that we faced was to get the single best answer. So we set the goal of the system to get the best answer with the smallest error value according to the fitness function. To do this, we studied the error rate of human manual counting using orthogonal arrays. There are three control factors in the error rate experiment, which are the size of the wood according to the thickness, the number of items per handling unit, and the total number of wood pieces per handling unit. So we found that the factor that has the highest tolerance was the size of the wood, and the size depends on thickness. So we use this value as the acceptable error rate. After that, we inserted this value as a constant value into the fitness function of GA to improve the selection of chromosome for the next generation to help in the predictions part. So we tested the GA method and there was a noteworthy decrease in error. So with this, finally, it helps to improve the efficiency of the system during the verification of the number of raw materials received. Another project, which is a more recent one, is this blockchain information management system for the LSP, Logistics Service Providers. You may wonder, what has this got to do with contactless logistics, right? In terms of contactless logistics, blockchain actually provides the infrastructure, which is the information infrastructure for it to operate effectively. As you know, blockchain can provide the transparency and has the tracking and tracing capabilities, and this made it suitable for connecting and managing IoT devices in the logistics environment, such as the vehicles, shipments, reliability. So in this project, which are still ongoing, we are developing a blockchain application for delivery logistics activities. So in this project, we built a prototype blockchain using Hyperledger Fabric version 1.4, which is basically a decentralized ledger technology platform with open source engine for blockchain solution. So how it works is that the user will interact with the web client to update and query the blockchain ledger and state, and the web client will then call the server, which is the Node.js application API, which is running on the back end. The Node.js application server will then call the Hyperledger Fabric to interact and submit transaction to the blockchain platform. So these are just some of the works that we have been doing in terms of contactless logistics. So I hope that all this shows some of the state of the artworks, and hopefully the next generation of contactless logistics will have all this implemented and make our society and whole city smart and efficient in terms of logistics. And here again, I would like to thank my students and my collaborators for making these research projects successful. Moving forward to implications, I believe the wave of contactless logistics is giving customers a whole new kind of experience. For example, the delivery robots, as I shown earlier, they are not full-blown multifunctional man-like robots, but they are actually cute little toy vehicles that carry around simple parcels and function with help of GPS, some few sensors, attached cameras, and typically move on wheels. And besides that, the use of e-payments, e-notification, digital signature are much more convenient for the consumers. So the consumers, especially the younger consumers, actually, I think they like it, as this technology provides the flexibility, efficiency, and convenience to them. The adaptation of new technologies such as AI, digitalization, and autonomous systems will further boost contactless logistics and will definitely help improve the efficiency of logistics systems, as well as be a value step towards low carbon logistics. And lastly, I believe the concentration of logistics will be further deepened after the virus epidemic. Smart logistics will play an important role in the upgrading of modern smart cities, and the use of contactless logistics will be more widespread, and it will be a norm in the society in the coming future. Before I end my presentation, I would like to share a short video about contactless logistics. with this, that's the end of my presentation. Thank you very much for listening. Back to you, Professor Ali.
Many thanks, Prof. Wong, for your sharing just now. It's very eye-opening and very interesting as well. And then the video is very catching as well. No? So I got one question passed over here, if it is okay with you. It says the implementation of contactless delivery involving advanced technologies like robots is most found in developed countries such as USA, Korea, and Estonia, as mentioned by you. Then what is your take for developing countries, and then what they should prepare this on the initial stage?
Thank you very much for your question. It's a very relevant question. As I mentioned earlier, countries like Malaysia is slightly lag behind when it comes to technology development. But the trend is there. We cannot run away from it. We have to follow the trend. We have to learn. We have to upskill our workers so that we can learn. We can learn from these developed countries. So I believe the government will have to start with education. They have to educate the younger generations to be good in programming, skills like Java, Python, all these have to be taught in school. STEM, science, technology, engineering subjects have to be pushed and put importance by the teachers on the students. And I think what is hindering the public from adopting this technology basically is the trust and the safety issue. I remember there's one research which is quite recent. In that research, the researcher actually carried out some studies to evaluate the public acceptance of this kind of robots, autonomous delivery robots. And that research was carried out during the COVID-19 pandemic period. The interesting thing highlighted by the researcher is that the willingness to pay for these autonomous delivery robots has a negative relationship with age. In other words, more elderly people will be more averse to this type of technology. But there is a positive relationship between income and willingness to pay. And also, in terms of gender, well, you may find this more interesting. Women tend to perceive higher risks about this technology. Men, they are more willing to accept this technology. Maybe it is true. Okay, and also I remember the study reveals that the trust and the tech-savvy attitude will actually have a positive relationship to willingness to pay for this ADR. So I believe maybe when the general awareness about the ADR technology increases and the delivery experiences start proliferating in public peer networks now, right? So easily you can share your experience on the internet, right? So the proportion of these consumers who are not willing to use or pay this, they will change their perspectives eventually. And on the business side, to counter for the lack of familiarity and trust towards this contactless technology adoption, perhaps the e-commerce companies and the maybe the on-demand the delivery platforms can focus on publicizing on the operational procedures and the potential advantages like delivery speed, flexibility, especially contactless handling, and convenience of these contactless technologies to the end users. Okay, so that is my opinion. Thank you.
Wai-Peng, thanks very much for your very insightful introduction about this topic. Although I was not quite familiar, but I do learn a lot from your speech. I just have a question, especially during this COVID-19. There are some person or even some city that were quarantined, so that create some difficulty to deliver food or medical material, etc. And of course, in your keynote, you share the video illustration how it can be done. But I just wonder, during this crisis, have you observed specific case that has been adopt those technology, and what were their lessons from those adoption? Thank you very much.
Thank you for your question. If I get your question correctly, you're asking about examples, whether
Yes.
I've seen or experienced this kind of examples before. Frankly speaking, I haven't. But on the internet, on the news channels, I have read and I have heard about the use of contactless logistics in hospitals, in quarantine zones. So basically, I guess the whole initiative of doing this is to reduce the contact between humans. In hospital especially, like in Singapore, they have started to use this kind of robots to send food and medicine to the patients. So in a way, it helps to reduce human contact, and also it ensures safety of the frontline workers. So I believe the use of these autonomous robots will prevail, at least for the time being, since we still haven't found a solution yet to the virus epidemic. And perhaps in the coming future, people will see the convenience, the flexibility, and also perhaps the lowering of the variable cost. When it comes to it in the long run, it will help to reduce the variable costs, operational costs. So perhaps in this kind of thinking direction, I believe the use of contactless logistics will not only be in the last mile delivery, but also it will expand to other industries like hospitals, and also the 3D jobs, dangerous, dirty, the 3D kind of jobs, especially like sending medicines to workers, to patients.
Thank you.
Thank you.
Thank you, Prof. Chen, for the question. That is a very relevant question. And thank you, Prof. Wong. I think we almost reached to our final, time for this. But before that, I would like to call if Prof. Cheng, Jackie, if you can give some closing remarks.
Just like to thank you, Professor Connor and Professor Cheng, for their opening remark. And thank you, Ali, for your thoughts, this very good section. And of course, we would like to thank you, Professor Wong Wai-Peng, for your great efforts to give this speech to our audience. And thank you very much. I think this will end up for this section. And thank you.
Thank you, everyone. Take care.
Thank you.
Stay safe.
Okay, thank you.
Thank you.
Thank you.
you. Bye-bye.
Bye. See you in next webinar.
Yes. Thank you.
So just end.
Yes.
Prof.